Hey everyone, today we're going to break down artificial intelligence. At its heart, it's really just about teaching computers to learn and think, almost like how a child figures things out. So let's jump right into the roadmap for how this all actually works.
Here's a quick look at our map for today. We're going to start with our destination. What's the difference between AI and ML? Then, we'll grab our toolkit of essential skills, look at the data that fuels everything, fire up the engine to see how machines learn, and wrap up with the really important rules of the road. Let's get going.
All right, first stop on our map, the destination. Before we go any further, we have to get really clear on the two biggest terms you'll hear all the time, AI and machine learning. So what is the real difference here? Well, it's actually pretty simple. Think of artificial intelligence, or AI, as the big ultimate goal. We want to create machines that can think, reason, and act like humans. Things like Siri or a self-driving car. Machine learning, or ML, is the main way we're getting there. It's the actual process of teaching a machine to learn from data on its own. Your email spam filter? That's a perfect everyday example. So really, AI is the destination, and ML is how we're building the road to get us there. Okay, so we know where we're going. Now, what do we need to pack for the trip? Let's take a look at the foundational toolkit, the basic skills you need to get started. It's kind of like learning your ABCs before you can write a story.
First up is math. And hey, don't let that scare you off. You seriously don't need to be some kind of math wizard. Just think of math as the language that AI speaks. It's how we take a messy, real-world problem and turn it into numbers and patterns that a computer can actually understand. Honestly, if you get basic ideas like averages and how to read a graph, you're more than ready to start.
Next in our toolkit, we've got statistics. If math is the language, you can think of statistics as the grammar. It's what helps the AI make sense of everything. It lets a computer look at a huge pile of data and find what's normal, what's weird, and what really matters. For example, it helps an AI figure out that most students score in the 70 to 80 range, so it can make an educated guess, not just a random one.
And of course, we need a way to actually give our instructions to the computer. That's programming. And when it comes to AI, the go-to language, hands down, is Python. Why? Well, for one, it's super easy to learn. It almost reads like plain English. Plus, it has tons of ready-made tools that let you start building really cool AI stuff right away.
So we have our destination and our toolkit is packed. But a car isn't going anywhere without fuel, right? And in the world of AI, the fuel, the single most important ingredient that makes this whole engine run, is data.
I mean, this slide says it all. Modern AI is absolutely useless without data. It doesn't matter if it's numbers, pictures, words, or sounds. Just like a little kid learns from everything they see and hear, an AI learns from the data we feed it. It's pretty simple. The more high-quality data you have, the smarter your AI is going to be. It is the absolute foundation of everything.
But here's the catch. Real-world data is messy. It is really messy. It's full of typos and mistakes. So a huge part of working in AI is just cleaning it all up. Because you've probably heard the saying, garbage in, garbage out. And this example is perfect. You might find a student in your data listed as 300 years old. Obviously, that's a mistake. And we have to fix things like that before our AI tries to learn from it.
Okay, so let's say we have this massive pile of clean data. Now what? How do you even begin to understand it all? It's like trying to find a story in a 1,000-page book by just looking at one word at a time. So how can we see the bigger picture? The patterns that are hidden deep inside all those numbers. The answer is data visualization. We turn those boring tables of numbers into something our brains can process instantly, like charts and graphs. Just a quick glance at this simple bar chart tells you a super clear story. People buy less ice cream in the winter and way more in the summer. No surprise there, right? But visualization makes complex data simple and helps us spot those important patterns right away. Okay, now for the really cool part. We have our tools, we've filled up the tank with clean fuel. Now it's time to turn the key, start the engine, and see how the computer's brain, the machine learning model, actually learns things. So, generally speaking, machines learn in three main ways. First, you've got supervised learning. This is basically like studying for a test with an answer key. We show the AI thousands of pictures of cats, and we tell it, this is a cat. Eventually, it learns to spot a cat all by itself. Then there's unsupervised learning. Here, there's no answer key. We just give the AI a bunch of data and it has to find the patterns on its own, like grouping customers together based on what they buy. And finally, there's reinforcement learning. This is all about trial and error, kind of like teaching a dog a new trick with treats.
The AI gets rewards for good moves and penalties for bad ones until it masters a task, like playing a video game.
Now, within machine learning, there's this extra powerful high-performance engine called deep learning. It uses something called neural networks, which are these complex systems that are actually inspired by the connections in our own brains. This structure lets them learn from just enormous amounts of data and spot incredibly complicated patterns. This is the cutting-edge tech that powers things like facial recognition, Siri, and self-driving cars.
Our journey is almost complete. We've got our destination, our tools, our fuel, and a seriously powerful engine. But for our last stop, we need to talk about the rules of the road. Because with any powerful technology, we have to think about how to use it responsibly. That's not just a nice idea, it's absolutely essential.
So as we build these amazing systems, we have to hit the pause button and ask ourselves some really important questions. Is this AI fair to everybody? Does it protect people's privacy? And could it accidentally cause harm? Thinking about this stuff isn't optional. It's just part of building good, trustworthy technology.
And it really all boils down to a few core principles. A responsible AI has to be fair, which means it works correctly for everyone and doesn't have hidden biases. It needs to be safe and reliable. It absolutely must respect user privacy. And at the end of the day, the whole point is to build tools that are actually helpful to people.
So there you have it. We've traveled the whole roadmap, from the basic ideas all the way to the engine of deep learning and the rules that guide us. AI is one of the most powerful tools we've ever created, and now you have a real understanding of how it all works. The road ahead is wide open and the possibilities are endless. So, the final question is really for you. How will you choose to use it?